Good afternoon. This is Jacqueline Russell and
Ryan Palermo
from BUCHI Corporation, and today we are talking about pet food production and quality using BUCHI NIR solutions. Thank you very much for joining us today. At the end of the presentation, there will be time to answer any questions you may have. Please feel free to type in your questions in the box provided on the screen. We have a lot of great information to cover, so without any further ado, let's get started.
I just wanted to provide you with a quick roadmap of where this presentation is headed today. We'll start by acknowledging some of the changing market and regulatory demands, then get right into NIR and how it applies to your industry. We'll briefly overview the NIR solutions offered at BUCHI, then look at using these solutions for everything from raw material assessment to process monitoring and final product release. Humans love their pets, and the numbers do not lie. Americans in the USA have spent over $21 billion each year to feed their furry little friends. And not just any pet food will do anymore. Pet parents are shopping with more scrutiny than ever before. We see market demands for organic-only brands, grain-free diets, and gluten-free formulations. Pet nutritional supplements are increasingly sought after, with an expectation for human-grade quality and safety. Concern for the safety of our animals by our regulatory bodies has also increased. Implementation of the Food Safety Modernization Act preventative controls for animal food calls for enhanced food safety management, including evaluation and reduction of hazards that may impact food safety, implementation of preventative controls to prevent such hazards, and specifications for good manufacturing practices, among other calls to action. Due to overwhelming market and now regulatory demand, pet food companies are expanding their quality programs. These programs include ingredient-based risk assessments and construction of state-of-the-art laboratories to test for nutritional composition, identity, and purity. Companies are also heavily pursuing food safety system and other industry certifications as proof of their commitment to quality and safety. So now we come to the topic of NIR and how this light-based technology can assist in ensuring the quality and safety of pet food products. NIR has broadly applied across many markets, including feed and forage, nutraceutical and pharmaceutical, food and beverage, and chemical industries. In the heavily regulated pharmaceutical industry, NIR methods are well established for GMP compliance related to raw material identification and qualification, as well as in-process and final product content uniformity. While these applications haven't been standard in the pet food industry, these practices can greatly facilitate preventative control implementation and hazard reduction. NIR has also been used quantitatively to produce the data used for nutritional or pharmaceutical label claims. But why do people use NIR when other wet chemistry or laboratory methods are available? Well, for one, NIR is very fast, on the order of 30 seconds per measurement. One NIR scan of your sample will produce all of your quantitative measurement results simultaneously. Secondly, samples don't need to be dissolved, diluted, or combusted in order to run an NIR method. Because chemicals aren't required for sample preparation, the economical and ecological impact of sampling is negligible.
Thank you, Ryan. Well, this is a great time for us to take a moment to review how and why NIR works for anyone not familiar with the technology. NIR is the acronym for Near-Infrared Spectroscopy. And by definition, it is an analytical technique used to determine the composition or identity of unknown samples by taking advantage of molecular vibrational absorptions occurring in the near-infrared region of the electromagnetic spectrum. NIR spectroscopy is utilizing the interaction of light in the NIR range, which is approximately 780 nanometers to 2500 nanometers, in between the shoulder of the visible spectrum and the shoulder of the infrared region. The range we are looking at is actually quite small. As an analogy, your eyes are also spectrometers that interpret light energy from the visible portion of the electromagnetic spectrum. So we know what type of light we are using, and we know that NIR spectroscopy is the interaction of light and matter. So now let's discuss what is happening with the matter, or in your case, the composition of pet food products and their raw materials. Molecules exist in a state of perpetual motion. They rock, bend, stretch, twist, do Pilates, yoga, interact with other molecules like 100 preschoolers at a birthday party, and you get an idea of the motion of molecules. So the molecules are moving. They have energy, just like all those preschoolers after eating cake. And specific molecules are associated with specific energies. NIR energy shares the same frequency of energy as organic molecules. So voila, they like each other. And the organic molecules will absorb the NIR light energy it likes. Organic molecules, OH, CH, NH bonds, which apply to water, fat, and protein. So when you look at the energies of organic molecules absorbed across the NIR region, you get a spectrum, like the one here. This is a beautiful spectrum of a higher fat pet food kibble. 23% fat is pretty high. I am a spectroscopist, so maybe I'm a little geeky thinking this is beautiful, but look at the CH stretch at the 1750 nanometer, which repeats itself at 2300 nanometers. The tall moisture peaks at 1460 and 1940, exactly where they are supposed to be. The whole spectrum is dominated by OH, or moisture molecular absorption. The moisture of this particular sample is only 8%, but look how tall those bands are. Oh, and the elusive protein, that NH stretch, intermingled with the OH stretch. Okay, I am a geek because still, after all of these years, I am fascinated by NIR spectra and all the information loaded inside such a small portion of our electromagnetic spectrum. I think it's pretty darn cool, and I hope you do too. So here, back to Ryan.
Thanks, Jacqueline. So now that you've had your quick NIR review, let's foray into the products that BUCHI offers to accomplish this pretty amazing science. BUCHI has been supplying high-performance laboratory equipment for over 75 years. Within our portfolio, we offer a variety of NIR solutions to accommodate sampling along various points of the pet food manufacturing value chain, from incoming good inspection to final product release. The product shown on this slide is the NIR or NIRFlex N500. The term flex is used to reflect the flexibility of configurations that this modular instrument is capable of assuming. This FT-NIR product has dedicated measurement cells for solids and liquids, as well as various fiber optic options. The NIRFlex N500 is typically dedicated to quality and R&D laboratories and can satisfy any IQ/OQ or 21 CFR Part 11 compliance needs. Our BUCHI NIR brings the accuracy of FT-NIR technology into production environments with ingress protection and a hygienic, easy clean design. This is the system installed in most of our food and feed customer sites. Both the food-grade PMMA and stainless steel models are shown here. The newest addition to the BUCHI NIRSolutions portfolio is the inline sensor called NIR-Online. Inline sensors offer the opportunity for continuous monitoring of critical product attributes and can be integrated directly into process control for process optimization in real time. The images on the slide represent the NIR sensor attached to various measurement cell accessories that can accommodate liquid and solid samples, as well as remote sampling above a conveyor belt. The system offers configurations for NIR sensing with or without an additional visible spectrometer and camera module. For our benchtop units, NIRware software serves as the operator interface and is used for data collection as well as data management and exchange for instance with a LIMS or ERP system. Centralized multi-site network management can be achieved using our NIR Anywhere software. NIR-Cal is our powerful chemometric software used to develop NIR methods when pre-calibrations are not available. And lastly, we have a variety of pre-calibrated or quick start calibrations in applications for the pet food and other allied industries. These applications can be used to begin data collection as early as day one.
In the next section of our presentation, we are going to speak about critical points in the pet food manufacturing process. Raw material inspection, perhaps after the extruder or the dryer, the oil sprayer, and analyzing the finished product. I will introduce which BUCHI NIR solution is best suited to do the job at each of these points and offer some examples and commentary of work that is successful out in the field. NIR is a major workhorse in the pet food plant, and most pet food manufacturers use NIR somewhere in their process. But my question is, does your plant take full advantage of the benefits of NIR technology at each critical point in the process? It's a rhetorical question for the manufacturer and something to think about as we move forward with the presentation. You analyze the raw materials, but what do you do with that information? How dependent are you on your vendor's certificate of analysis? How well do you connect the dots with what is happening at intake and what the results are for the finished product? How well does quality control communicate with production personnel? And sometimes I think this is the most critical question of them all, and I think you would agree. Ryan and I are going to focus on quantitative and qualitative control on what is coming into the plant. Greater controls at this step in the process can alleviate a lot of uncertainty and trouble downstream, improve product consistency, and greater consumer confidence. In actuality, if implemented properly, the NIR is in fact a money-making machine, because using this technology throughout the entire manufacturing process and taking corrective action when needed, you will find what one plant manager calls, and I really like this phrase, money on the floor, or money saved by doing what you do, only better. And I know with 100% certainty, plant managers love finding money on the production floor. Well, NIR is a great tool for sniffing out some of this money, increasing yield without increasing costs. When the NIR is implemented for incoming raw materials, instead of accepting every vendor's load of material, you can reject outright bad ingredients and force the vendors to do better or cease the relationship. You have a greater potential to negotiate a discount for out-of-spec material that you could still potentially use but not pay that premium. And something my colleague Ryan is going to talk about in a minute is qualifying nutritional supplements. And this is something I know a lot of production plants are not doing. And all of this data helps the manufacturer bring their formulations closer to target and minimize their protein giveaway. And all of this is happening before you even start moving these ingredients through production. For the majority of incoming raw materials, the BUCHI NIR FT-NIR is an ideal solution. As Ryan mentioned previously, it is ingress protected IP54 or IP65, and that can be chosen depending on the specific needs of the environment the unit will reside. And the same sample presentation is used for dry ingredients as used for meat and the nutritional supplements and even some liquid ingredients. It is capable of qualitative and quantitative measurements, super easy to clean, super easy to use for anyone on the production floor. The BUCHI NIR is a reliable, easy to use NIR solution. Pet food manufacturers purchase a lot of different dry ingredients for a lot of different formulations. Our customers have been successful grouping most of the incoming dry ingredients into one setting on the BUCHI NIR. Imagine trying to keep up with all these different calibrations in all these different product settings. From cornmeal to chicken meal and everything in between, we can predict protein, fat, and moisture with one easy application channel. This plot represents NIR protein predictions collected over about a year and a half using a lot of different incoming dry ingredients. This particular subgroup shows ingredients above 30% protein, and it's predicting with an accuracy of 1% protein. Validating the protein content of these incoming dry ingredients within this level of accuracy allows the manufacturer to tighten his rations and help alleviate protein giveaway. Of course, we also measure moisture and fat for these dry ingredients, and as you can see from this data, the standard error of prediction is 0.3 and 0.66% respectively. The same concept for the incoming dry ingredients also applies to the incoming raw meat. Grouping all the meat types into one calibration reduces the burden of managing the NIR. This is much better than having to have these separate calibrations for all these different types of meat products. In this case, a pet food manufacturer collected meat data during the course of about a year using BUCHI's meat calibrations. We ultimately added this data back into the calibration to make it more robust for this particular company. There were even some unique meat products our calibration had never seen before. And even though our calibrations had never been exposed to venison, for example, or that we were aware of, the results lined up nicely with the rest of the meat products. So in this case, fat predicted with a standard error of prediction of approximately 0.7% fat, moisture 0.8%, and protein 0.36% across this entire range of different and unique meat products. And now, back to Ryan.
Maybe you were already aware that many pet food manufacturers have been using NIR for quantitative analysis of raw materials, in-process, and finished products. However, one application that is being underutilized is the qualitative inspection of raw materials, especially as they pertain to dietary supplements. You can think of qualitative analysis as an equivalence test, where a current sample is compared to a library of quote-unquote good samples. So long as your products or ingredients are carbohydrate, fat, or protein-based, they will contain the carbon, oxygen, hydrogen, or nitrogen-based functional groups required to get a signal in the NIR spectral region. Moreover, the fast data collection time enables 100% inspection. That means you could potentially check the identity and quality of every single bag, barrel, jug, or vat that enters the warehouse at the cost of about 30 seconds apiece. Best of all, your operator will get a simple pass or fail result. No complicated data analysis is required for routine use. So what might be the benefit of inspecting incoming raw materials? Consider that raw materials are the building blocks of your products. Identifying quality issues upon receipt of these materials will avoid costly issues downstream. Some potential causes for unsafe or poor final product quality related to your raw materials could be mislabeled ingredients or incorrect ingredient grades, incorrectly labeled nutritional profile, or worst case, contaminated or adulterated raw materials. You can use NIR to check that incoming raw materials meet specifications with qualities consistent with their price and accurately reflecting their certificate of analysis. Consistent raw materials enable predictable manufacturability and processing, and most importantly, final product consistency, quality, and safety. Consider this fun example to better visualize qualitative analysis. What if each piece of fruit in this illustration was labeled by the supplier as a red delicious apple? Well, it would be pretty easy for an operator to determine visually that an orange, Granny Smith, and a rotten apple were either A, misidentified, or B, of insufficient quality. However, we aren't dealing with such obvious scenarios. In many cases, particularly with these nutritional ingredients for more medicinal use, we're dealing with inconspicuous white powders. Visual inspection is no longer adequate to differentiate these materials with confidence. Moreover, the potential to visually identify contamination or adulteration in such samples is infinitely low. So how does NIR work to qualify raw materials? You can think of each NIR spectrum you collect as a fingerprint. Samples that are of the same identity and quality will have nearly identical fingerprints, so when an operator collects their spectra, he will get the pass test result. If, however, the sample has different physical or chemical characteristics, the test will fail. The identity test is the result of some mathematical operations happening in the background within the software, specifically principal component cluster analysis. This next slide is an illustration of what's going on behind the scenes when you collect an NIR spectra for an identification method. What principal component analysis or cluster method does is that it finds the commonality between spectra of the same substance, like our apples. Those substances then form a group or cluster of points in a new coordinate space. Here we'll show in 3 dimensions. In an identity test, you'd expect a sample to fall within the cluster of points formed by samples of the same identity and quality. This figure shows an example of a cluster model with 5 different raw materials, where each unique raw material is identified by its own color, whether teal, green, blue, red, or magenta. Consider the teal cluster in the upper right quadrant, and that represents our red delicious apples. When we collect a new spectrum of a red delicious apple, indicated by the small teal triangle, it fell into the teal cluster. In this example, our ID test would give us a passing result. Now look just off to the right of the red delicious cluster. You see a new sample that fell very close to the cluster, but it was just outside. Consider that that sample may have been from a different orchard, or maybe it was a less ripe apple. It had some source of spectral variation that wasn't covered by the original calibration model. In the context of our white powders, we might see a result like this when we receive lots from a new vendor, or maybe the particle size of the powder was unique to our calibration set. In that case, we would fail the ID test, but we could augment the calibration set with these new sample spectra to make the calibration more robust to those sources of variability in the future. In the lower left quadrant, we see a cluster of magenta samples representing spectra of navel oranges, and we have one of our supposed red delicious apple spectra aligning with that cluster. In this case, our ID test would again fail. But the software would also report back that the spectra of our sample would have passed an ID test for navel oranges. Lastly, look into the upper left quadrant. Here we see a spectra that is well outside of any cluster in the model. This tells us the sample is very unique to the rest of the spectra in the model and may indicate either A, a completely new substance, or B, a contaminated or adulterated material. In this case, I show a rotten apple, which would have had dramatically different spectral characteristics due to both chemical and physical changes accompanying spoiling.
Okay, so we covered all that NIR can accomplish for raw incoming materials, and that was a lot. I sure hope you took notes because you'll be quizzed by Ryan at the end of this presentation. Haha, just kidding. Okay, so now we're going to change gears a little bit and talk about how NIR can be implemented into the actual production process using a NIR-Online process sensor. A NIR process sensor allows production to continually visualize their process. This is the only way that they can really see what is happening minute to minute, hour to hour. There are multiple points in the production process where we can utilize NIR to gather critical product information. With that information, production managers can respond in real time to bring their process back in spec, optimize production efficiency, and/or protect margins. Consider an NIR sensor directly after the drying step. Feedback from the NIR sensor will enable production to push moisture closer to the critical spec to improve profit margins. If the product is coming out with too low moisture concentration, production can reduce the drying time and potentially save energy costs. At the same time, protein and fat will be continuously monitored to verify formulations that have not deviated from target. This picture is illustrating an NIR online installation on the side of a paddle conveyor. This is measuring animal feed. It's just an example of what a NIR-Online installation could look like if you wanted to place the NIR sensor on a conveyor. Without a continuous monitoring scheme, production has to be extra conservative with their targets and limits. Here, the upper production control limit is set to 9.5% moisture to allow some deviation without risking out-of-spec material. Out-of-spec material would be anything above 10% moisture. Although the control chart shows that the process is relatively in control, there is some wiggle room here to push that working target just a little bit higher and improve profit margins. Because the NIR provides real-time feedback, allowing rapid process adjustments to keep the moisture in spec, we can safely push that upper control limit to our critical limit of 10%. That 0.5% moisture will pay great dividends, as we'll show in the following slide. Here's an example for one production line pushing an additional 0.5% moisture into dry kibble. Assuming one production line produces 100,000 tons per year at an overall cost of $1,000 per ton, adding 0.5% moisture into the product over 1 year means you sold 500 additional tons of water without compromising quality. That generates roughly $500,000 in annual savings just for that specific product line. Your return on investment for an NIR sensor could potentially be less than 2 months. Now, this is a very rough estimate and example, but I think you can see the potential for the money on the floor with one NIR sensor on one production line. Another location to place an NIR sensor is after the oil sprayer. Here you have the ability to monitor your oil levels in the kibble, and if you see a sudden drop or inconsistent fat concentrations, you may be alerted to a blockage in the sprayer. Here's a picture of a NIR-Online sensor mounted above a conveyor belt, which could accomplish such tasks. Now, naturally, you want your production process to be consistent and predictable. In the left plot, you can clearly see an unstable production process, and you could never see this pulling only one grab sample every hour or every half hour. You would not be able to see your process. Actually visualize what is happening. Well, with the addition of an NIR online sensor, all of those deviations and jumps in the process can be visualized and followed with root cause investigation. Maybe that oil sprayer was blocked, or the dryer temperature is deviating. Again, this real-time feedback allows production to bring that process back under control. Once the pet food product is packaged and ready for shipment, further rapid testing is required by NIR to document the production run and validate the label claims. And of course, NIR technology allows the manufacturer to test final product with much higher frequency than could ever be achieved using traditional wet chemistry methods. Again, the BUCHI NIR is a perfect solution to test final products. And wow, look how accurate the data can be when you compare NIR predictions with an awesome laboratory. This is a data set collected by one of our pet food partners who graciously shared this comparative data. The data was collected over a 2 to 3 year span and shows how accurate their BUCHI NIR performed in the field. Over this large range of protein, and I have no idea how many different formulations are in this data pool, The protein standard error of prediction is just over only 0.25% protein. Moisture the same at 0.25%, fat 0.3%, fiber 0.2. Now please note that in this case the kibble was homogenized with a grinder before NIR analysis to optimize calibration performance. So now you can see where BUCHI NIR-Solutions fits into the pet food production process, from incoming raw materials, inside the production lines, and final product verification.
And that's a wrap. Thanks, Jacqueline.
Well, thank you, Ryan.
And of course, thanks to our audience who joined us online today. At this time, we'd like to open up the floor to any questions or comments you may have. And it looks like we have a couple here. The first is, how will the temperature and pressure affect the in-process monitoring of protein and fat?
I can answer that question. When you have higher temperatures, then you will see variations. But in this case, the temperatures are going to be about the same, and so we calibrate for those temperature variations, and we incorporate that variation into the calibration to make it less sensitive to those effects.
Okay, and the second question is, how do you use NIR to identify inorganic raw materials? And the answer to that is that you really shouldn't be using NIR as a primary method for inorganic materials. However, because inorganics do scatter the light, and the spectrum that we get is a combination of both the absorption events and the scattering events that occur when we illuminate a sample, we can sometimes get away with identifying or quantifying even some inorganics in an organic matrix, but it's not necessarily something that we would be approving.
There's another question.
And then we have, what attachment would you recommend for NIR testing of finished products? For example, a petri dish, a vial, etc.
Well, for finished products, I would recommend the NIR is a great solution as the NIR, and we have a petri dish that's called the Unbreakable Cup. It's made of silicone. It's like a silicone band, and it's about near indestructible. So that's perfect for the production floor. It won't break. And it looks about like a petri dish.
Yeah,
it's about the size of a petri dish.
It's a little deeper than a traditional petri dish would be.
Yeah.
Okay, it looks like we've answered all the questions. We'll hang on in case anyone is just typing out their question. And if not, we appreciate, once again, everyone joining us today. And please don't hesitate to follow up with us at buchi.com/US or give our office a call. And, of course, we gave the email addresses on the previous slide. Thank you very much. Here we have one more question. Would the Unbreakable Cup work with the NIRFlex N500? So we have different add-on accessories for the N500 so that we can accommodate different petri dishes and the high-performance sample cup and the Unbreakable Cup. So yes, we can accommodate an Unbreakable Cup with the NIRFlex N500. And just to reiterate, if it didn't come across in the presentation, the NIRFlex N500 and the NIRMaster are actually an identical spectrometer, and the only difference is the ingress protection offered on the NIRMaster makes it better suited for the production environment, but of course you lose the flexibility of changing the measurement cell. So a NIRFlex N500 with our solids measurement cell is equivalent to the NIRMaster setup, but of course without the ingress protection.
I think hang on for just a few more minutes to see if there's more questions.
Yep, we'll stick around in case anyone has any additional questions. And again, thank you for your time.
I think that's it.
Okay, with that, we'll just end the webcast. Thank you very much for your questions and again for your attention. Have a great day.